So we were looking at another question regarding the equation of a straight line. So we have this given equation that we need to solve. We need to, we're not solving this equation. We want to rewrite this equation in the form of y is equal to mx plus c. After doing that, then we're going to write an equation that is parallel to that equation uh, through the given point 1, -13. Very simple. Now, at all times, we want to try to have the original or the given equation into this form. Y is equal to mx plus c. And so let's get straight into it. So, but there is a rule. There are some information that we need to remember when we are asked to write any equation that is parallel to another equation, or any line of an equation that is parallel to any other line of equation. It's very simple. And if you remember, let's say recall, parallel lines are lines that go in the same direction, but they never meet. But guess what? They share the same gradient. And that's a key thing of parallel gradients. Now, if we rearrange this given equation into the line that's into the equation that says y equal mx plus c, once we have the gradient for this equation, we do not have to solve for the gradient of the other line that is parallel to this equation. Because remember, if we have two lines, we have two gradients. So gradient 1 will be equal to gradient 2. And that's just a rule when it comes to lines that are parallel. Now, if you remember the other video, sometimes students tend to mix up perpendicular lines gradients and parallel lines gradients. So please do not get it mixed up. So when we have parallel lines, the gradients of both lines are the same. But when you have perpendicular lines, the gradients is like one is the opposite of the other one, or it is a reciprocate type of looking thing of the other one. So the parallel gradients are always easy to represent or to identify, because you're not really finding anything, you're just identifying it, or say or state what it is, because you're not really solving for it. So let's go back. Now, also, and you recall, we always remember that whenever you're asked to write an equation that is whether perpendicular or parallel, we always go back to the original equation that forms, well, this is the original formula that forms this standard equation, which is the equation of the line y is equal mx plus c. So this formula gives birth to that equation. And so we can't solve this problem. We can't rearrange this and then try to represent an equation that is perpendicular to this given line unless we make sure that we are using up this formula. So let's go straight ahead and see what we get. So let's go. Now we always try to rearrange this equation. As I always been saying, rearrange this equation in this form. That's the first thing we do. All right, so let's go. So all we need to do is have the y on one side and all the other terms on one side, because if you look at the equation, y is a subject. Y is always on the one side. So we're going to have all the y terms if we have more than one on one side. If not, we just keep the one y that we have. So let's go ahead and try to do this. So the first thing we're going to try to get rid of is this -12, because it is on the side where the y needs to be by itself. And so we need to get rid of this -12, which if we were to get rid of this, we must apply the opposite of this -12. But before we do that, let's try to look at this, because here's a problem that we have on this side. It's so messy. So let's try to work out the side that has the parentheses and all that crazy thing. Let's go and try to work it out. Now, if you look at this right now, we could actually get this organized in a way understandable way. So what we're going to do is to do what we call the distributive property. We're going to distribute -3 by that and by that. And so we write back over to 7y minus 12 is equal to, so -3 times +3 gives us a -9. -3 times -x gives us +x. Remember, when you multiply a negative, positive 3x. Sorry. Whenever you multiply a negative by a positive, it gives you positive. Hold on, let me see. When you multiply a negative by a negative, it gives you positive. And when you multiply a negative by a positive, it gives you a negative. And that's why we have a -3 times a +3 gives you a -9. And we have a -3 times a -x gives you back a +3x. And so we need to remember the rules, all right? So since we would have simplified this part, let's go ahead and try to finish this part. So we want to have this on it by itself, well, mainly the y. So let's take our time. So remember, whenever you have something looking like you have like 2 terms or 3 terms or 4 terms, and you want to have only one of them by itself as a subject, we always get rid of the term that is farthest away from what we want by itself. That's the first thing we get rid of. So if you look at this, the 7 is attached to the y, so this is the 7 will be the last thing we move. And we're going to move this -12. So the opposite of this term is a +12. Whatever I do on one side, I do the same thing on the other side. That cancel. And so what we have now is 7y is equal to -9. I'm going to shift this over and bring the 12 right there. I'm going to put that right there and right there, right? So we're doing good. And all we need to do is group the like terms on the left and on the right hand side right here. So let's get some space right here. Let's see what happens for this right here. So let's get right there. Erase everything right here so we can have something more organized. So let's go back to this right here. So we have 7y is equal to -9 plus 12 plus 3x. Now, when I see a negative, I'm saying that I owe that some amount of money. So if I owe $9 and I have $12 in my pocket, when I pay the $9 from the 12, I'm left with $3. So I write back this right here. So we have 3 plus 3x. But we're not finished because we need to make sure that the y is by itself. So what we're going to do now is to do some more erasing. So we have this so far. All right, so we have 7y is equal to 3 plus 3x. And so we need to have a y by itself. And so in order for us to get rid of the 7, we have to apply the opposite operation of what is joining these two. This is a multiplication between the two. So the opposite of multiplication is division. So we divide both sides by 7. That cancels that. And now we have a y by itself. But guess what? This 7 is dividing both terms. And so we have to write it like this. So we have to write everything like this right now. Let's see. There's like 2 more steps and we're finished rearranging this equation. So we have y by itself. And then we have 3 over 7 plus 3x over 7. But this is not necessarily in the form that we want it to be, because what we always want it to be, it really doesn't matter how you write this. You could have this as your answer, but for some person, they prefer to make sure that the term that has the x is at the front right here, while the constant goes at the back. And so that's all we're going to do is rearrange it. So we actually rearranged this equation, but the expected form is to have it like this. Y is equal to, so we're going to take this part, which is the mx. So this is our gradient. The x is that, which is the same x. That is our m. So we have 3x over 7. And this is our constant c, which is just 3 over 7. And so we have rearranged the equation in the form that we want it to be. Very, very simple. Very, very, very simple. And so what we're going to do now is to make sure that we look at what we need to do in while we look at this equation. This is the equation that we're going to write another equation of. We're going to write another equation so that it shows some parallel features to this equation. And so this equation is actually coming from this. Let me just erase this right here. Get rid of this right here. So this equation right here is coming from this. This equation that I circled, that is just circled, is coming from all of this, because the aim is to rearrange it in this form. And if you look at this, that's the y. My gradient is 3 over 7. My x is right there. And my constant c is right there. And so it is in that form. So we could just erase this right now. No big deal. So the equation that we are working with is this. This is the equation that we're working with. So the idea is, remember, we must use our original equation that gives birth to the equation of the straight line. We must remember that. The point, so the only thing that I need to write the equation that is parallel to this equation is that I need a point and I need a gradient. That's all I need. I need a matter of fact, I need 3 things. I need a point, the gradient, and the formula. That's all I need. So I have my formula. That is one thing. My point was what? It was, I think if I remember, it was +1, -3, -13. And if you look carefully, this is gonna be my x1. This is gonna be my y1, right? And if you look at this carefully, you see a y1 right here, you see an x1 right here, and these coordinates are going to substitute into the formula right there. So we say we need 3 things: the formula, the point, and we need a gradient. But what would be the gradient? Now remember, the rule says any line that is parallel to any line, they share the same gradient. And so if let's say I have this line right here, let's draw this line right here. Any other line that's going to be parallel to it, it's going to go beside it. So if this line has a gradient of 3 over 7, then guess what? This line also has the same gradient. And so by default, we have our gradient for the second line, which is going to be the parallel line to that original line. And so we have all 3 pieces of information that we want. So let's move on. So remember, we need the formula, we need the point, and we need the gradient. That's all we need. So let's plug these values in. So what is my y? Now remember, so this y is just this y is the y that's going to be left in the equation that looks like this. This y is this y right here. This y is one of the coordinates, and this x is one of the coordinates. This m is going to be the gradient, and this x is going to be the x that is always in the formula. And that is actually the breakdown of this formula. Nothing hard, very simple. So let's go back. Let's put down our information that we have. So our y, which is going to be the y in the equation, is going to be that. Our y1 was what? -13. Put in parentheses. What's our gradient? The gradient is the same thing as that because it is parallel, right? What is our x? X is a standard thing, or x1 is +1, right? And so there's an x there, so the x, there's a negative there, so the negative is always gonna overrule any positive number once there's an x. The once there's a negative, when there's a negative in front, it's always going to overrule if there's an original positive number. And so we have this as the equation. Y minus 13 is equal to 3 over 7 bracket x minus 1. That's what we have. So remember the point was positive 1, negative 13. This one goes right there. That 13 is right here. And our gradient from the line goes right there. Somewhat a little bit messy, but we have the idea right now. So let's go ahead and finish it. So we have negative 13 is equal to 3 over 7 x minus 1. And all we need to do, my friends, is to rearrange this equation so that it is modeling this. And that will be the equation after we would have gotten the variables, the terms in the equation. So let's move on. So what's the first thing we do? Well, let's look at the easiest one. Now, we could just simplify going across. Like, let's try to. So if we have two negatives clashing, remember, it's always going to become a positive, right? So these two negatives clashing positive. Now I could just simply distribute what is the scale value outside into by distribute it back to all the terms that are in the parentheses. So if I have 3 divided by 7 times x, I will get 7 times x. If I times 3 over 7 by negative 1, I get negative 3 over 7. Remember, when you multiply a negative by a positive, you get like a negative. If you multiply a positive by a positive, you get like a positive. And so what we need to do now is to get rid of this 13 so that the y is by itself in the equation. The y by itself, the y by itself. And so we need to get rid of this positive, this 13. What's the opposite of a positive 13? The opposite of this positive 13 would be what? Be negative 13. Oops, I don't like that. Let me go back to this, right? This is better right here. So we subtract both sides by 13. That cancels that, that cancels that. So what we have now, I'm just going to erase this because we need some more space. What we have right now is y by itself, because the 13s were canceled. Then we have 3 over 7 x minus 1 minus, oh no, let's go back to this. We have minus 3 over 7 minus 13. Yeah. Right. And so far, we have our y is equal to mx plus c. Well, guess what? Here looks messy. So we need to fix this up. Very messy. But here's a quick way we could actually, because we need to work this out. These are like terms. So we could just try to find a way to simplify. Now, if you remember fractions from your previous grades, I could simply come up with another way to write negative 13 is just to put a 1 there to create a fraction. But the idea is it is so easier to solve fractions if the denominators are the same. But the denominators are not the same because the denominator for this fraction is 7 and this one is 1, right? So if let's go back. Now, remember, I could represent any number, any whole number as a fraction just by dividing by 1, because 1 does not change the value of the original number. So if I had 16, how could I write 16 as a fraction without affecting the 16? Divided by 1. 1 divided by 16 gives you 16. And so that's what I did right here at the top, right here. I have a negative 13 because I want to work with fractions. This is a fraction and a negative whole number. I just want to work, well, not a negative whole number, but a number that is not a fraction. So in order for us to have fractions with fractions, I could just simply create a fraction by dividing it by 1, which would give you back the same negative 13. It doesn't affect the negative 13. And so it is easier to work with fractions, subtracting fractions with fractions or adding fractions with fractions. And so that's why I created this fraction right here. So all I need to do is to make sure that these denominators are the same. Now, they are not the same because we have a 7, we have a 1. But the question is, what number could I multiply this with by so that it becomes a 7? Obviously, 7. Whatever I do for the denominator, I do the same thing for the numerator. All right? So let's try to rewrite this, because this is like a what you call an equivalent fraction. For this, okay? An equivalent fraction, so no big deal. So if I were to look at, if I were to simplify this right now, if I have 13 times 7 gives me 91. Right, give me 91, right, 91. Right. So if I were to just to rewrite this in a better way or simplified way, I would have negative 3 over 7 minus these two at the top gives me negative 91, and this at the top gives me 7. And if you look, the denominators are the same. Remember, in fractions, when the denominators of two fractions are the same, you could just keep one of the denominators and then you just add the numerators or subtract the numerators depending on the operation that is in the middle. And so that's what we have right now. So let's go ahead and simplify this some more. So we have y is equal to 3x over 7 minus 3 over 7 minus 91 over 7. So since the denominators are the same, we could just keep one of them in our answer. So we have negative 3. We have negative 3 right here over all over 7 minus 91. And we could just simplify this some more. Now, I love to do my math in detail. So if it looks very long, just know that I'm a teacher who loves to do my math step by step so you can see the whole process of doing it and the procedure. So we just had negative 3, negative 91 all over 7. Now, if you look at this right here, we have, so it's like, whenever I see negatives, I'm saying that I owe that some amount of money. I owe. So if I owe $3 and I owe 91 more dollars, I'm owing $94. And so this fraction right here is gonna be simplified into this. Negative 94 divided by 7. And there you go. We are finished. So that is y is equal to mx plus c. The y is right there. Our gradient is right there. Our x is right there. And the constant c is the negative 94 divided by 7. And there you go. Writing an equation that is parallel to a given line when you're given the point and you use the same gradient, because the gradient of any two parallel lines are equal. So there you go.